Do we have any question or anything? I don't know. Did you follow me? I don't know who. Has anybody want to any question or anything? I finished maybe a bit.
Hello.
Yes, I finished.
Yeah.
I finished.
Hello.
Yes.
Okay.
Thank you, Professor.
Okay.
Hello.
Yeah.
I have a small question.
Yes.
Okay. On page 50 of the PPT, I still don't understand why phi eta at x1 and x2 is always continuous.
Remember. Okay. Nice question also. Okay. Remember. What we need is to compute when we interpret using shape function. Again, we will compute gamma integral over gamma of element. Our function is f of r. This could be t between xi and x, or it could be u between xi and x. This is f of r. At the end of the day, it is xi and x. And this one will be multiplied by phi of eta, multiply the density function u or t. If we have t, we will have u. Okay, u at eta, or or t at eta. Okay, because we have 2 times the Jacobian at eta. So we could have t with phi and u and the Jacobian. The alternative way, we have u times the phi times the t times the Jacobian, right? We have 2 integrals, right? Okay, again, I will write it again. Maybe. So we have either in the edge matrix, we have this one. T times the phi, t of r, times the phi of eta, times u of eta, times j of eta. In the G matrix, we have integral over element times u of r, times the phi of eta, times the t of eta, times the Jacobian of eta, right? We only have these 2 integrals, okay? Any integral like this, we change it to between eta equal 1 minus 1 to eta equal 1. We change this between, and this is the purpose of the appearance of the Jacobian here. Okay? Sorry, this is eta equal 1. Okay? That means this is summation over Gauss points of the integrand times the weight at Gauss points. Okay? So we need to compute phi and the density function. This is nodal coordinate actually. This is not. I'm sorry. This is not of eta. This is a nodal coordinate. This is constant. Okay. So we need to compute at every Gauss point. So we have this is the eta element. This is the eta, and this is our element in nature. This is gamma. So at every element here, we put 4 Gauss points, for example, to carry out the integral. At certain eta, so eta here is known, eta here is known, eta here is known, eta here is known. Okay? Okay? So we can compute the Jacobian, we can compute phi of eta, it's straightforward. But the question is, I want to compute the value of the fundamental solution. So I have one of 2 ways. The first way is to change all the fundamental solution to be in terms of eta, and this is very difficult. Or to change eta here to get the point here, the corresponding point in the xy plane. Because of that, we need to interpolate this point in terms of the xy plane to be able to compute the distance r here between the xi point and the point xy. In doing so, it's very important to understand that all the integral here is carried out over the element, even if it is discontinuous element. The discontinuous element, if I have discontinuous element, so the nodes between here and here, so this is the first part of the element and this is the last part of the element. Outside these two, we have more than, for example, the shape function here is 1, and outside this, you will get more than 1 here, okay? So you extend beyond the element. But when you compute the value of the coordinate x and y, it should be between the extreme points. You can't use this you can't use this small error element. You can't use it. You have to have the full gamma. You have to have the full gamma. It's almost continuous. Otherwise, we will have small gaps. This area, if we use the discontinuous element, these parts will be gaps in the geometry. We will not have a closed contour. And our boundary integral is derived based on changing the domain integral to boundary for a closed contour. We will not have a closed contour. Because of that, when we interpolate x and y, when we have interpolate x and y, we should use a continuous shape function. But if we interpolate u and t, we could have any. Actually, we could have isoparametric element or superparametric element or subparametric element. It depends on the value of the shape function we will choose. Maybe next time we'll talk about this one. I hope that I'm clear. If I'm not clear, I'm going to repeat this in the coming lecture. The first thing I'm going to repeat it in the first lecture, this point also again. Okay.
Thank you, Professor.
I knew it is because of that I divide the quadratic element into 3 lectures actually, because I always send some ideas every lecture, but in the coming lecture we wrap up everything together. Okay.
Okay. Thank you, Professor.
Welcome.
Yeah, so any other question? If no, Professor Rashed, yes. I would ask if the possible, because I see the next week, maybe the holiday in China.
Okay.
The memory for the I think the memory for the past people.
Okay.
Yeah.
So we'll drop the coming week and we'll continue the week after.
Yeah. So maybe is that possible? We next week we do not have a lecture and
okay, sure.
I mean the 2 weeks later we start the 11th.
Sure, Professor.
Okay, lecture.
Sure,
yeah,
Paul.
because the holiday, I think some students they will go back to their hometown to memory them their the past family.
Okay,
yeah.
Sure.
So
sure.
yeah. Okay. Yeah. So see you 2 weeks later.
After 2 weeks. Okay.
So
again,
yeah, thanks for all.
Want any question? I am on WeChat, on WhatsApp. I'm ready to reply any question at any time. Okay.
Yeah. So I agree about your idea that we still need many people to join us to do the BEM research. So yes. I think that maybe in the later the lecture, is that possible you may give some topic like about the open problem in boundary element method.
Sure. Sure. But
yeah,
maybe
so
this one after 3 lectures from now, because we need to finish the quadratic element. We need to talk about how to derive fundamental solution, outlines only. Then we need, this is very important lecture, we need how to transfer domain integrals to the boundary. This is very important. After that, we will talk about dynamics, nonlinear problems, fluid mechanics, anything. There are a lot of open areas. Okay?
Yeah. Okay. Yeah. So then, if no other questions, so we close today's lecture. So thanks very much.
Okay, thank you,
Professor Rashed,
okay,
for your teaching, and also thanks for all the students you participating. Yeah. Okay. So see you 2 weeks later. Yeah.
Bye.
Bye.